From this lecture, let's try to understand how Spring Data and Spring Data JPA frameworks they are going to help developers by handling all these steps of database interactions. The very first step is establishing a connection. Let's try to understand how these frameworks they are going to handle this step. As a developer, we just have to define our database details. As of now, inside the application.properties, we are defining our database URL, username, and password, and what is our driver class name. Based upon these details, behind the scenes, during the startup of the application, the Spring Data and Spring Data JPA, they are going to create a connection with my database. Those connection details will be available in the form of a bean. The same bean is going to be used by my frameworks whenever I give instructions to them to interact with the database and perform an operation. Do you see how simple it is? We just have to provide some properties, and behind the scenes, the magic of creating the connection and maintaining the connection is going to take care by the frameworks. When using Spring Data JPA, please make sure this property is also defined. With the help of the spring.jpa.database-platform, we are giving a clue to the Spring Data JPA framework. What is the type of database dialect it has to use to connect with our database? Let me open the documentation of this property. This property we need to use to name the target database to operate on auto-detected by default. Can be alternatively set using the database enum. Here the official documentation is telling, based upon the dependencies that we have added like H2 database, Spring Data JPA is smart enough to detect these dialect details. But like I said before, it is always recommended to mention these properties so that if someone is looking at your properties, they can easily identify what is the type of database that your application is using. Apart from this property, we should also mention spring.jpa.showSQL. By default, the value will be false, but let me try to set the true. With the help of this property, we're telling to the framework to enable logging of the SQL statement. As I said before, the SQL preparation and execution of the SQL statement is completely going to be taken care by the frameworks. As a developer, if I want to see what are those SQL statements that are actually being executed on top of my database, I can see them inside my logs by enabling this property. You need to use this property only during the development phase. Whenever you have a scenario where your Java code is not working as you expected while interacting with the database, these SQL logs, they are going to help you to a great extent to debug and identify the actual issue. Throughout this course, I'm going to enable this property, but like I said, don't try to put this property into the production application. After establishing a connection, we're expecting the framework to create the SQL statement, execute them, process the results, and convert them into POJO objects. But to perform these operations, we need to tell to the framework our table details, how we want to represent our tables, and what are the operations that we want to execute, whether we want to execute a select query or update query or delete or create query. All these details we need to tell to the framework by making some small configurations. Let's try to understand how to make them. Whatever code changes that we are going to make, these changes, they are going to be one-time activity. Once you set up these entire configurations and code base, everything else is going to be taken care by the framework out of the box. As a next step, I want to create a POJO class which represents my database table. As of now, inside our database, we have created a table with the name products. I need to give a POJO class to the framework representing my table structure. Let's try to create the same POJO class. Here I'm going to create a new package with the name entity. Under this entity package, I'm going to create a new Java class with the name product. Since I'm expecting the object of this product class to represent a single record of my products table, I'm trying to use product but not the products. So please make sure you're also following the same. On top of this class, you need to mention an annotation at entity. This annotation is coming from the Jakarta library. As I said before, Spring Data JPA inspires a lot of its concepts from the Java Persistence API. That's why it is trying to use the annotations from the Jakarta library. Jakarta library is nothing but Java Enterprise Edition library. If you try to open this annotation class, using this annotation, we are specifying that a specific class is going to act as an entity. In the Spring Data ecosystem, entity represent a table inside the database. Since our application is going to have hundreds of Java classes, we need to give a clue to the framework which classes are representing database tables. We are going to give that clue with the help of this entity annotation. After the entity annotation, we need to use table annotation. To this table annotation, we can pass name as products because the table name should be whatever you have created inside your database. Products is the table name. That's what I'm trying to use here. In case if your Java class name and table name is same, then mentioning this table annotation is completely optional. Now I have a class ready. As a next step, I need to define Java fields inside this class representing each of my column. Let me try to do the same. The first field is private long product ID. Please make sure you are mentioning the field name same as your column name. In case if there is an underscore is present, you can remove that underscore and convert the first character of the next word as a capital letter. That's what I'm trying to do here. Since the data type of my product ID is big int, I'm trying to use long here. After the product ID, I'm going to create the next field, which is the name, which represents name column. After the name, I'm trying to create a field with the name description. After the description, we have price, which is of type decimal. After the price, we have popularity. Maybe I can try to create the popularity here with the private integer and the field name as popularity. Here also, instead of double, we can try to use big decimal, which is more optimal in this scenario. After the popularity, I have image URL column. The same I have created with the data type as string. If the data type of your column is varchar, inside Java, you need to mention the same as string. The next columns that I have is created at, created by, updated at, and updated by. Let me create fields for them as well. The very first field I'm going to create as created at of type instant, because inside created at, I'm going to save both date and time. After the created at, let me type private string created by followed by private instant updated at, and towards the end updated by is the field name. Here you may have a question, which is what if I want to use a different Java field name compared to my column name? You can do that happily, but when your Java field and column names are different, you need to make sure you are using an column annotation on top of your field. Under this column annotation, you need to provide the name of your column. Here I'm trying to provide the name of the column product underscore ID. In this scenario, I don't have to mention these column annotation because the field name and the column names are matching exactly. There is no need, but I'm trying to mention them for your reference. In future, when you are looking at this code, you need to know that there is a possibility of providing the column name manually with the help of column annotation. Apart from the name, using column, we can also mention nullable as false, which means the column associated to this field, it is a not null column. Let's try to do the same for all not null columns. Most of my columns are not null columns except this image URL and this updated at and updated by. Let me mention at column annotation here with the name as name and nullable as false. I'm going to do the same for description as well. After description, I'm going to mention for price. These are all the best practices that you need to follow. If you don't mention this nullable as false, framework will never know that this column is a not null column. And eventually, when it is trying to perform the operations directly on top of the database table, it is going to face some runtime exceptions. To avoid all those scenarios, it is always better to provide as much information as possible to the framework by using these annotations. Coming to the image URL, it is a nullable field. That's why here we can mention nullable as true. But anyway, the default value itself is true. That's why we don't have to specifically mention here. Let me delete the same, followed by on top of the created at, I'm going to mention column with the column name as created at along with the nullable as false. Let me do the same for created by as well. For the last two columns, since they are nullable columns, I can simply mention name of the column. Now I have done all the column related changes. As a next step, we need to tell to the framework which of these column is a primary key inside the table. If we hover on this error that we are seeing, the framework is expecting a primary key field inside our entity. That's why it is throwing this error. Entity does not have a primary key. Inside our table, we know product ID is a primary key column. That's why on top of this primary key column, we need to mention an annotation at ID. ID is an annotation that we can use to convey to the framework that a specific field is a primary key column inside the database. When we are dealing with the primary key value needs to be generated by someone. We need to tell to the framework whether the primary key ID value will be generated by the developer or it is going to be generated by the database or the framework needs to take care. To convey the same, we need to use an annotation at the generated value with the strategy as generation type dot identity. Whenever we are mentioning the generation type as identity, we are telling to the framework that the primary key ID value will be generated by the database itself and it is going to take care completely around the primary key ID value. As a developer, I don't have to provide the primary key ID value while I am trying to perform insert operation, and similarly, framework also don't have to worry. Behind the scenes, whatever database that I am trying to use, the same it is going to take care. Now we have created Java fields inside our Pojo class, but we should also create getter and setter methods so that frameworks can use those getter and setter methods to set the data into this Pojo object or to read the data from this Pojo object. To create the getter and setter methods, we can go towards the end and press Command N, followed by we can select these getter and setter. I want to generate getter and setter for all my fields. Let me select all of them and click on OK. Now I have getter and setter methods inside my entity class. But there is a better way that we can use to avoid generating these getters and setters manually. Let's try to understand what is that approach in the next lecture.